talk today about hello again. Sorry. Now, can you hear me all right?
Yeah. Only
So,
one having
yeah, I'm good.
dropping in and out today as well. So
Bad day for
that to
happen.
yes, Thursdays are obviously a bad day.
Right. So So yes, I'm going to talk about automotive cybersecurity and particularly an MBSE take on the new standard, which is ISO 21434, DIS meaning Draft International Standard. So first of all, I like to frame the problem. So here's a little image showing what we're talking about. So I'd like you to imagine that you're in your car and you're about to go for a drive. Your car's a connected car. So it's connected to your home router, and then as you set off, it connects to a 5G base station, which links you to a server that links you to another car that's linked to the traffic lights that are changing color to slow it down at the right point. Then that's all connected to a much wider network of things, buses streaming video to the passengers, and people downloading internet content into their vehicles. And each of these connections provides a potential path for attackers to attack the vehicle. And this is perhaps not such a good idea, but it's what the automotive industry want to do and need to do to facilitate autonomy and to facilitate. As soon as you connect your car to the internet, you have to think about cybersecurity, because it enables your vehicle. And so next slide, just bear with me. So what's the problem? Why does that matter? Well, we've got all of these connected systems, and there's going to be ever more devices sharing ever more data. And when those devices are killer machines on wheels, there's a risk to life to being tracked.
So that's that's a good marketing line there, Stephen, for the automotive industry.
Well, indeed,
on wheels.
You know, there might be other concerns that you have about your privacy other than being tracked. You know, that your driving styles being monitored and all sorts of things. Your vehicle has suddenly become a complex part of a complex nested system. It's now part of a system that's got unprecedented complexity. There's a lot more code and a lot more ECUs on your vehicle than there are on pretty much any other type of device on the planet. The landscape that you're navigating is ever changing. So people are trying to vehicle, and as soon as the manufacturers find a flaw and patch it, they'll be looking for new. And the now is not just a car for moving you from delivering other products and services.
You're getting lots of dropouts. At least I am.
Are we okay now?
don't know whether I'm the only one getting them. It might just be. Are you dropouts as well?
Yeah, I'm getting dropouts.
Yeah, okay. Well, I think we're just going to have to live with it then, Stephen. It's obviously just an issue at your end. Everybody's getting dropouts apparently today. Yeah, Stephen, you're just going to have to carry on. I think it's obviously we're all being affected by it. So
I'm terribly sorry. We tested it yesterday, and there was
yeah, it was fine, wasn't it? I mean, Peter's getting dropouts from me as well, so I think it's it could well be a Teams issue. We have had a number of advisories come up on the admin console over the last couple of days with Teams advisories. So I think you're just gonna have to carry on, and we'll manage. We've got the slides that we're looking at anyway. So. Coming back. Did you deliberately leave and rejoin there?
Yeah, it was glitching too much. So hopefully we've got a more stable connection there. Right. So apologies about this. We did test this yesterday. And
yeah, we had no problem at all. You'll have to reshare your screen, I think.
Okay. Yeah. Okay, hopefully you've got my my screen again. Can you hear me now, Simon?
Yes, I can hear you. Your screen's come through, yeah.
Okay, right. So yeah, and currently automotive cybersecurity doesn't have any. There's some. The EJ3061 is the prominent one amongst those. There's PAS 1885, which is a British standard publicly available specification, but there's no nothing that would be recognised as an official ISO standard. However, that is being worked on, and that the draft of that standard is the main topic of conversation here. So. We've talked in previous weeks about safety versus security and how much overlap is there between the two. And as engineers, we're always looking for potential for reuse of capabilities, but it's important to be aware of some differences. So if we look at this comparison table, you'll see that there is harm from unintentional actions and harm from intentional actions in security. So that's a pretty important difference to be aware of. So we're not talking about hazards so much as threats. And that means that whereas in the safety world, the nature of hazards is relatively static, you can expect the spill on the road, an oil spill on the road, to be pretty similar in 10 years' time as it is today. But with security, it's a dynamic, fast-changing environment, and the nature of threats can also change during the lifetime of the product. And you have to expect that to happen and build the resilience into your system to be able to deal with that. There's that we need to take to. Safety we've achieved in automotive by extreme similarity with a low probability of deviation. So we put exactly the same chips in exactly the same place in exactly the same boards, and we have really tight controls to make sure that everything is done with good tolerances and operates exactly the same to a known level of safety. With security, if we make everything the same, unlike safety, where we can expect a bell curve failure of the units out in the field, with security, as soon as one's compromised, so you get a very cliff, and that means to understand and act on emerging system failure. So you have to have a much more, as a systems engineer, you really need to be thinking a lot more about the operational phase of the life cycle than maybe you have previously in automotive. And that also contrasts to safety, where the causes of failures are mostly known at design time. In safety, we rarely require updates. If we've done the engineering well, then hopefully the product will get through its life without a major recall. But with security, we'll be expecting to make updates as standard. And that's one of the big drivers for the automotive industry connecting cars to the internet, is that they can then do over-the-air updates. But if you're expecting to update things like braking systems, steering systems, critical systems that are critical to life, then that means connecting those systems to the internet as well. And that there's a massive trade-off there. And that's why we need really solid cybersecurity in automotive. So this is the layout of the new standard. It's a risk management system, essentially. So hopefully that's familiar to people working in engineering. The scope of this management standard is electrical and electronic systems within road vehicles, and it aims to provide a vocabulary, objectives, requirements, and guidelines, all fairly familiar, good stuff for systems engineers. I'm particularly focused on the vocabulary today, and it's a critical look at the way that the vocabulary is being dealt with in this standard. So with this standard, we're looking to enable a common understanding throughout the supply chain, and really that the vocabulary is the underpinning fundamental basis of that common understanding, which is why that's where I always start and why I tend to focus on that in my research. The standard also helps you define your cybersecurity policies and processes, manage cybersecurity risk, and very importantly, in my view, foster a cybersecurity culture through your supply chain. And it implements, as I say, a cybersecurity management system, which includes risk management in accordance with ISO 31000. So even if you're not in automotive, I'd recommend going to have a look at ISO 31000 if you're not familiar with it. It's a lovely short standard, which is always appealing. It's concise, and it's a good piece of work in integrating risk management activities and functions. Diagram, you can see a bit or a meta model, terms you describe this type of thing. Don't get too excited as a model-based systems engineer, because this is about where it stops. Interestingly, the relate with the text in the and important issues that you. In this case, the security relevant items are on the vehicle service parts. So there's a few practical considerations. First, to think, well, this is a system of systems, a cybersecurity consideration at the, or more accurately, perimeter electronic and electrical systems. We're going to have something else other than this standard that covers the interactions beyond the vehicle. And it also includes aftermarket and service parts. So that means as an engineering organization, you've got to have a way of communicating all your risk management that is critical to the cybersecurity to your aftermarket network. And that is a very important thing that the standard does. But one of the things that's been criticised in the draft is that that's not being done well enough. And there's potentially quite a lot of IP considerations affected in sharing that type of information. So I'm just going to quickly whiz through a few of the sections. I'm not going to cover all of it. If I just previous slide, if you look at that, it's a life cycle. We've got project continuous cybersecurity activities, and then concept phase, product development phase, post-development phase, production, operation, and management. Onwards is concentrate on the earlier parts of the standard. Here, management. If you're familiar with ISO standards that deal with management, then this will look fairly familiar to you. And it's all about the organisation instituting and maintaining governance and a cybersecurity culture. And cybersecurity culture is really important because a lot of organisations, particularly traditional engineering companies like a lot of the automotive manufacturers, don't have a cybersecurity culture. Safety culture has been developed. So if you've been involved in developing safety culture, whatever industry you're in, there might be some parallels you can follow there to help develop the cybersecurity culture in your organisation. Now, this standard splits the risk management into two types. So there's overall governance type stuff which applies to whatever project you're doing, and then it asks you to do certain activities specific to the project that you're working on. An interesting aspect here for systems engineers is this out of context development. Now that means that you're allowed to develop a part not knowing which vehicle, which overarching system it's going to end up in. And that's how supply chains work. They develop parts, circuit boards, and chips. So that has to be in there, but it does mean that there's a significant bit of project dependent stuff to do when you get that off the shelf part and incorporate it into your wider system. So it's good that that's been recognised. And then you've got continuous cybersecurity activities which have to go through the whole life. And your objectives there are to collect the information, triage that information to sort the wheat from the chaff, assess any events that happen, and then use that information and that analysis to identify and analyze vulnerabilities and then manage those vulnerabilities, which might involve you going back to an earlier stage of the life cycle and redeveloping parts of your software or even parts of the hardware. And the standard allows for that, and it allows for these iterative loops through the life cycle. So we've got risk assessment methods as well, which determine the extent to which a stakeholder can be impacted by a threat scenario. Now, here's where we start to get into some interesting vocabulary issues. As a systems engineer, we have a pretty clear idea of what a stakeholder is, but here a stakeholder is intended to be a road user, and the business is at liberty to add other types of entities to that definition of stakeholder. phrase is different to the definition of stakeholder in the vocabulary that of the standard. So what we're trying to do with risk assessment, well, we're trying to identify assets. So those are the things that are cybersecurity relevant, what properties they exhibit, and the ways that they could be involved in damage. We're looking for threats that could lead to something that causes damage. And what we have to do then is rate the impact of those identified scenarios. And there's 4 categories: safety, financial, operational, and privacy. Then we're going to look for the paths that realize that threat scenario. And we're going to try and assess the ease with which those paths can be actioned. And that gives us the opportunity to determine a value for the risk. And once we have a value for this, we can select the appropriate risk treatment options. So risk treatment has various possibilities. You can remove the risk. You can mitigate the risk, reduce its consequence. You can accept the risk, let it go. And that part of that is doing business, and there's a lot of risks involved in connecting cars to the internet that are being accepted. Or you can outsource that risk, so you can put that onto your suppliers or some other part of the wider enterprise that you're collaborating with, or you can share the risk. So the standard then comes up with some risk assessment methods. And these follow that prescription that we just looked at on the previous slide. These correspond to the various things that you need to identify. So you're looking for the assets, trying to identify threat scenarios and attack paths. Now 8.7 is interesting because this is the only section that implies any type of requirement about the method that you use. So it's a should, it's a recommendation, it's not a shall, but none of the others are even as strongly worded as that. So there's three methods that are mentioned, and if you're not going to use one of those, that implies that you need to have a good reason for not using one of those methods. And we've done it because of this this additional level of requirement. We've done a bit of research into that, comparing these methods, and some interesting results coming out of that. And we found that, based on some very on a very lightweight study, we found that they don't give the same results for the same scenario, and that's quite interesting. So we're looking to develop that into some guidance for the industry on how to choose between these these methods. So. So that's an overview of the standard and its structure. Now, what I'd like to do is now talk about the vocabulary and how I've developed that into a conceptual model. So we saw a little chunk of a conceptual model on figure 2 earlier. Now, I wanted to comment on this standard, and being a model-based systems engineer, my first action was, my first thought was, well, to try and understand the conceptual model that underpins this. And it proved to be a very interesting exercise, and it developed into quite a big exercise, as you'll see from this slide. So that's the conceptual model. It's not complete, there's more that needs to go on there. And at this point, I'm just going to switch to Enterprise Architect because it will make it a lot easier for you to see what's going on there. So just bear with me. Okay, so hopefully now you can see Enterprise Architect on my screen. Could you just confirm that for me, Simon?
Yeah, I can see it. Yeah, that's fine. We are still getting a lot of dropouts quite a bit with you, Stephen, by the way. So you know, I know there's nothing we can do about it, but just be aware.
Okay, so what I've done just to aid readability is added a bit of color coding to the SysML here, and so the black text is terms that were defined in section 3. Then blue text is things that were mentioned in section 3, section 3 being the vocabulary section. Green text is things that I had to infer, and purple text is things that were mentioned but weren't included in the vocabulary. As you can see, there's quite a lot of filling in needs to go on. And now it's a really interesting exercise to model a standard, and Simon and John have done that for 15288, and it's not an easy thing, but it's very revealing and it's a very useful exercise. So if you are involved in implementing standards and working in model-based systems engineering, I would highly recommend this exercise, because you will gain a much deeper understanding of the standard, and potentially come up with some very important insights that you can then feed back to the organisation developing the standard, which is what I did, and it was very well received. So I'll come back onto that in a little while. But first of all, I just want to take you through some examples of the standard. So the reason I want to do this enterprise architect is because I've got the information stored in some notes. So if I click on the road vehicle cybersecurity block there, you should see down in the right hand corner the notes, which is the definition that's in the standard. Hopefully that's big enough for you to read in the notes box. Is that legible, Simon?
It's legible to me on my iPad, yeah.
Okay, right. So you can see here that if you remember, the black is things that are defined in the standard. Now, the first thing to observe is there's very few relationships that are clearly defined in the standard. You have to infer these, or they're mentioned outside. They're mentioned in other parts of the standard that are not the vocabulary, and that's a really important fact for me, and something I think that standards in general need to get better at addressing. So if we look at the definition here of cybersecurity, this was a bit of a shocker to me. So that is a condition in which assets are sufficiently protected against threat scenarios to EE components of road vehicles and their functions. Well, yeah, it's a little bit hard to work with as a definition for me, and very importantly, very different to other ISO definitions of cybersecurity, very different to 27000 series, which is information security, that you've probably come across. So that was a bit of a surprise. And then if we look at the definition of an asset, this is where it starts to get even more weird. So this is something for which the compromise of its cybersecurity properties can lead to an damage to an item stakeholder. Now that really heavily relying on a lot of other definitions, and we'll look in a minute at how that actually has caused some significant problems, like circularity in the definitions. So assets have cybersecurity properties, and those properties are attributes of the asset. And here we've got something that is more recognizable as a security engineer, which is confidentiality, integrity, and availability. And these properties here are about the most unambiguous thing in the definitions. And so I've used them as a basis for a new set of definitions, which is what we ended up proposing to ISO through the British Standards Committee. So just while we're on this diagram, I wanted to have a look at something else that's relevant to systems engineers. So our beloved 15288 system lifecycle process standard gets a mention, and it gets a mention in the form of the definitions of verification and validation. Now, partly what I want to point out here is it's a cautionary note about when you're working with standards and assuming that you know what terms mean. So here, if we look at verification, that has been taken directly from 15288, confirmation through the provision of objective evidence that specified requirements have been fulfilled. So if you look below that, I've got the definition from 15288, and it is exactly the same without the note to the entry. So you could be forgiven for thinking, oh yeah, I know what's going on here. But then we look at validation. And so here we know the keyword here buried down there is modified from 15288. So that's a little bit awkward, because it means that to really understand how your world is changing, if you try to implement both of these standards in parallel, you have to go and look up the other definition. I've done that for you here in the note box below. And it's actually quite a significant modification here. So if we look at confirmation through the provision of objective evidence that the cybersecurity goals instead of requirements. So we've already moved up a level of abstraction potentially there. You know, what we understand as goals generally are more abstract, less easy to measure than requirements. And here we talk about, in 15288, we talk about fulfillment of requirements, whereas here, because we're talking about goals, we have to come up with some notion of adequacy and achievement. And because the goals are not necessarily as well defined as requirements, that could be difficult. So as a systems engineer, you've got a hidden problem there. That could cause you some quite significant problems down the line if you haven't picked that up early in the process. So at that point, I would like to switch back to my presentation. So just bear with me 1 second. Hopefully I'm getting a bit slicker at this now. So there's an, can you see the presentation again, Simon? Hello, Simon, can you see the presentation?
Yes, I can, yeah.
Okay, so there's a zoomed out view, and what I did was that you notice there's a lot of white space there and some dangling connectors, and what those connectors do is they connect to all the problems that I found as I was modeling this. So Sorry, Stephen. That's bonkers. Yeah. So I was meant to show you this with this little trick in Enterprise Architect. If you use Enterprise Architect, it's got things called layers, which work very similar to layers in Photoshop or that type of tool, if you've ever used those. So I've got a toggle, and every time I put one of these red boxes on there, it gets put onto a different layer, so I can switch them off to help me visualize the diagram better, and that's been a very useful trick. Now this prints out with a size 12 font onto an A0 piece of paper, just to give you some idea of the scale of the complexity. And at least half of what's on there was stuff that was not on the not in the vocabulary. It was concepts that I had to deduce from trawling through the rest of the standard in order to be able to link together the concepts that were defined. So there's other concepts that are introduced, didn't have obvious dependencies to the vocabulary section. I've limited my work to making sure I could understand the vocabulary section. I haven't been through and identified everything, and there's a bigger modeling job to be done, but this is the type of thing that you'd have to do if you were to bring a standard into your MBSE working environment. And so what you do, if you want to go back to the ISO commit, there's some problems with this. All has to be translated into this table. It was a tedious process, but actually that process of putting the comments on the diagram, having them in situ, getting myself sorted, it was then a fairly simple process of transcription. The reason I've included this screenshot here is because this is the standard ISO commenting template. And what you'll notice here is that there's PDFs. So those two previous slides there I was actually able to submit those to the ISO as embedded PDFs on the standard commenting template. I hadn't realised that was possible, and it was only a tip from somebody I know who's on the committee that allowed me to do that. So that meant that I could actually make my conceptual model directly available to the experts working on the development of the standard. And yeah, I was expecting this to sort of get brushed off, oh, this is too much work, what's going on? But I had an amazing reception from the British Standards Committee. And the way this works is that you give your comments to the Standards Committee who are developing the standard. They're at national level. Each country then triages all of the comments that have been submitted to the national body to remove duplicates and make sure that they've understood all of the comments locally. And I got invited onto the group call with the committee, much to my surprise and satisfaction, to discuss this. And what was originally scheduled for a 4-hour meeting got extended twice with another 4 hours worth of meetings, in large part because my conceptual modelling had thrown up so many obscure problems that were, and I was very pleased at how seriously they took this and how appreciated it was. So it was a very so what I'm saying is, don't be shy about trying to contribute to standards. And what I've learned here is the earlier you can engage with them, the better it is. I didn't have access to it until the draft international standard came out, although everything was well received, it's a little bit late in the process for them to really make wholesale changes. But what we did come up with, we ended up putting in a proposal to change some of the fundamental definitions. So I mentioned when we were looking at the diagram about cybersecurity properties. So the draft international standard definition had confidentiality, integrity, and availability. But it mentions of something else. So I'm going to go through some issues with this. I'll come back to that one. So here, this is the type of issue that's very hard to spot if you're just reading the document. But when you're trying to when you put it into a ontology diagram, comes leaping out at you. So here we've got adverse consequence or undesirable result. But in the definition of an attack, it just speaks of adverse consequence. So that suggests that there's a difference between undesirable result and adverse consequence. Actually, it turns out that wasn't the intention. So the undesirable result part was removed in comments then. So here we've got something else interesting. The scope of the standard is electrical and electronic systems, but when we're talking about attacks, it talks about items or components. Now, the definition of item says it's a system or a combination of systems to implement a function at a vehicle level. So you see we've got the scope of the standard talking about systems, including components. We've got the definition of item talking about systems and combinations of systems. But here we've got items or components or the environment. So we've got different levels of abstraction being dealt with in a very awkward way there that's potentially going to cause some big problems in the way that the systems develop. So I mentioned earlier we've got some circular definitions. So if you look here at cybersecurity property, uses asset in its definition, but then when we look at the definition of asset, that uses cybersecurity property. So from an ontological point of view, that's a big no-no. So I'm going to whiz through it. It doesn't have to be like this. There's a really interesting standard just come out a couple of months ago called for innovation management, called ISO 56000. And in Annex A, they actually have a conceptual model. It's not as robust and rigorous as we'd probably like to see from an MBSE perspective, but it's a step change in rigor in terms of understanding the underlying model of a standard. So I was very pleased when I came across this. And actually, this is one that's of great interest to the cybersecurity community in the UK, which is why I picked up on it. So, yeah, if you do get involved in any of this, which I'd encourage you to do, there is a precedent. So I mentioned earlier on that even if you are doing this work, the scope of the standard stops at the perimeter of the vehicle. So you're going to have awareness of a lot of other standards. Now, there's a really interesting report just come out last week called the ResiCav report. It's been run by the Automotive Electronic Systems Innovation Network in association with MIRA and with Coventry University. And this piece of work was actually done by Warwick University as well, and they looked at all the standards that might affect automotive cybersecurity. So that's a really good resource if you're involved in this type of system development. I'd strongly recommend getting a copy of that report so that you can find out all the other standards that might be of relevance to you. And part 2 of that report is quite interesting. I think I've run out of time to talk about that, so I'm going to have to skip over that very quickly. But this is all about the trying to calculate the risk of catastrophe, and to minimise that based on understanding and minimising so maximising the probability of detection, increasing the number of engineered differences, which I alluded to earlier, and making sure that you're continuously and proactively updating things. And by doing that, you reduce your catastrophic incidents to a small corner of a cube, if that makes sense. It's explained in the standard. The link's at the bottom of that page. You have to go to the link, put in your email, and they'll send you by email a link to a Dropbox with the full set of reports. And there's a lot of other feasibility projects that have also got their reports in that repository. So in summary, connected vehicles are part of a constantly changing complex system of systems throughout their life cycle. The standard is not built on a solid conceptual model, unlike some other standards. And that was, when it was pointed out, it was well received. And then the existing standards do not adequately cover operational resilience in particular, and that's this part about having to have a continuum of proactive updates. So this was all focused on automotive, but hopefully you found that whatever industry you're in, there's some lessons to be learned there and some useful things to take away.
Thanks ever so much, Stephen. Apologies everybody for the communication issues. It's out of our control, unfortunately. Lots and lots of things to think about, and as Stephen said, although this is an automotive cybersecurity standard, I would imagine that many of the concepts apply to any kind of cybersecurity, and maybe that's something we can touch on in the social at 11 o'clock for those of you that are going to come along and join that. Does anybody have any questions for Stephen now? Otherwise, we will finish and have a social at 11 to 11:45. If you've got a question, let me know now. Otherwise, we'll end. Okay, I'm not seeing anything coming through. Nobody's speaking. Okay. Thanks, everybody, then. As usual, the recording of the presentation will be put up on our YouTube page. And Stephen, can you make the presentation available? Are you okay for me to put that on our website for people to download from our knowledge base?
Yeah, I think so. Yeah.
Yeah, brilliant. That's fantastic. So the presentation will be available from our knowledge base as well. If you haven't already got access to the knowledge base, you can get that through our website, and I'll send you the link to that. So thanks again, Stephen. It sounds to me like we might need a follow-up presentation at some point, looking more at the resilience aspects of things, because I think that sounds like it's a very interesting topic in its own right.
Great. Okay.
So thanks everybody, stay safe, and hopefully you can join us in another 12 minutes for the social at 11. Cheers, thanks, bye.
Bye.